Here's number 5. Determine a rational function that meets the given conditions and sketch its graph. The function f has a vertical asymptote at x equals -2. So let me start with that. So a vertical asymptote at x equals -2 means that we're going to have a function, f of x, that has x plus 2 in the bottom of the fraction, right? Because the zeros of the denominator, that doesn't get canceled out with the zero of the numerator, that's going to make us the vertical asymptote. So if you see x equals -2, that means this function has a 0 of x equals -2 in the denominator. So that's why I wrote down x plus 2 in the bottom of the fraction. Okay, now let's look at the second condition that says horizontal asymptote at y equals 4. So for a function to have a horizontal asymptote at y equals 4, it needs to have a leading coefficients ratio to be 4. So I'm going to give you an example to kind of remind you of these horizontal asymptote rules. Let's say that you have y equals 10x plus 1 over 5x minus 2. I just made it up, okay? Now, when the degree of the numerator and the degree of the denominator, like the biggest exponent on top of the fraction, biggest exponent in the bottom of the fraction, those are called degrees, right? If they are the same, okay, it's x to the first power and x to the first power, right? The horizontal asymptote is simply going to be the ratio of their leading coefficient. So the ratio of the leading coefficient is 10 over 5, which is 2. Okay, so this applies when the degree of the numerator and the degree of the denominators are the same. So if it was something like, I'm going to make up something else, okay? 3x squared minus 1 over 3x, not 3, I'll do 5x squared plus 3, then notice that the degree of the denominator and the numerator are both 2. So since they are the same, we have a horizontal asymptote of y equals 3 over 5. Okay? So this rule applies when the degrees are the same. If they are different, then, we have talked about those other rules before, right? So if you want to have a horizontal asymptote at y equals 4, hey, we can do this. How about I just say 4x on top of the fraction? Because now take a look. The number in front of this x is 1. So if I take the degree, if I take the ratio of these leading coefficients, notice how 4 divided by 1, 4 over 1 is 4, right? So by just putting 4x on top, I met the second condition. Now there is that third condition about f of x equals, I'm going to highlight that, f of 0 equals -2. Now what that means is, if we plug in x value of 0, if I plug in 0 into this function, I better get -2 out of it. Okay, so I'm going to see if my current function satisfies that third condition. If not, I will try to fix it a little bit, okay? So if I plug in 0 into the function, what will I get? I'll get 4 times 0 over 0 plus 2, right? This is not going to work. Look, I have 0 over 2, which is 0. Now, this is not going to work. Not working. So once I check that this doesn't work, I have to fix, I have to think about how to fix my f of x so that it comes out to be -2. Now, think about this for me, okay? I'm going to change some numbers around. I don't want 0. I want -2. That's what they want, right? They want f of 0 to be -2. So if I change this to -2 on this side, what should we change about the numerator here? What number needs to be sitting on top of the fraction if I want something divided by 2 to be -2? Well, that number's got to be -4, right? Because -4 divided by 2 is -2. So now that's going to work. So what I know is that the numerator, the top of the fraction, better be -4. So let me see. If I have 4 times 0, that's not going to give me -4. So how about I say I will do 4 times 0, but I will subtract 4. Because 0 minus 4 is negative 4, right? So I think I fixed my problem. Now, instead of saying just 4x, how about I say 4x minus 4? Oh no, where did that go? Give me 1 second. Let me bring up my tablet again. All right, so I think I fixed the issue, okay? By putting minus 4 on top of the fraction, I will be able to get f of 0 equals negative 2. And I still have a vertical asymptote at x equals negative 2, and I still have a horizontal asymptote at y equals 4. So, last thing I need to do is sketch this function. Okay, so these were my work, okay? But I have my answer here. All I need to do is graph this. So, if you have a graphing calculator, this will be much easier, but you don't need a graphing calculator to graph your x-axis, y-axis, and these asymptotes. So let's try to do it as much of it without it. So I'm going to plot 1, 2. Here's my negative 2. Here is 1, 2, 3, 4. And I will also go down negative 2. Okay, first of all, I will have a vertical asymptote at negative 2. So I'm going to draw a vertical dotted line at negative 2. Okay, that's my vertical asymptote. Now next, I need a horizontal asymptote at of y equals 4. So at y value of 4, I'm going to sketch a horizontal line. Okay, so I got that. Now, last condition was to have a point at 0, negative 2. So here's my point at 0, negative 2. All right, I know the graph will look like this. Like, to the right, go down, get really close to that vertical asymptote, and I'll have a piece like that right there. But if I want to be super accurate, the more the points, the better the graph will be, right? So if you want to plot some extra points on your test, we have one already. We have 0, negative 2. You may be able to use your graphing calculator's table of values. And while at it, let's check our answer too, okay? So I'm going to go to Desmo's graphing calculator on my computer. And you guys can use your calculator, the graphing calculator too. So I'm going to type in the answer that I think is correct. 4x minus 4 over x plus 2. Now I'm going to see if this has a vertical asymptote at x equals 2. Okay? I'm going to graph x equals negative 2 in a dotted line. Does it have a vertical asymptote at x equals negative 2? Yes. As the graph gets infinitely close to this red dotted line, you can see this graph is going up. The right limit is going down. So it does definitely have a vertical asymptote at x equals negative 2. Does it have a y equals, the horizontal asymptote at y equals 4? And to me, yes, it does look like it. As x gets infinitely big, it is approaching that green dotted line from below. And as x gets infinitely small to the left, it is approaching that green dotted line from above. So I do have this graph that has a vertical asymptote and the horizontal asymptote as it required. And what if I plot a point, 0, negative 2? Will that purple dot be on the graph? And yes, it is. So this looks great. So, but you can go to your table of values and try to plot more points if you want. I can see that I have a point at 0, negative 2. I got that graphed at 1, 0. I can plot a point at 1, 0. Because, when you graph rational functions, like we try to have at least 2 points on each curve. So I have 2 points over here, but I wonder like what kind of points we will have to the left of this red dotted line. So I'm going to plug in some numbers that are smaller than negative 2. So what if I plug in negative 3, negative 4, negative 5, negative 6, and negative 7? Okay. I can just graph any of those two and just have a graph. Negative 6, 1, 2, 3, 4, 5, 6. And I'll plot a point at 7, 5, 6, 7. So my graph is kind of off, but It will be nice to have these graphed to have a more accurate graph. So I'll have a point right here. I was just graphing 6, -7, and I'll have another one at -5, 8. So this is -5 and up at 8. I'll have another point right here. But then the graph will look something like this. Okay. And that's what we have over here on the graphing calculator. So I will ask you to write an equation and just sketch its graph. I did some extra work by finding 3 additional points, but as long as you sketch something that has that vertical asymptote, that horizontal asymptote, and the point I ask you to have, that's going to be okay for your sketch part, okay?